Okay. Muscles act by getting shorter, right? Everybody understands that. But that's a rather simplistic understanding of it, and we have to understand the situation beyond that. Muscles apply force to the ends of their attachments on the bones. And since they are contractile muscles, they apply the force of tension between those 2 points. We're going to talk about the different forces in just a second. But let's talk about muscle action first, okay? Here's my 15-pound dumbbell. Now, I'm going to start down here, and I'm going to curl this dumbbell, right? What just happened to my bicep? What? No, that's what happened to my elbow. Flexion happened to my elbow because flexion and extension are joints. You know that magazine called Flex? That's a stupid name. It refers to a joint, not a muscle. Okay, we don't flex muscles. We do different types of actions on muscles. So if I start down here and I make the ends of my biceps shorter, which act to, in this particular instance, to flex my elbow, then I have performed a concentric action. A concentric action means that the muscle exerted force while it's shortened, while each of its ends came closer together. That is a concentric muscle action. Okay? Now, I'm going to lower this dumbbell, what bodybuilders call the negative. All right? What's my muscle doing now? It's getting longer, isn't it? So it's performing an eccentric action, right? So if it gets longer under a load, it is called an eccentric action. If it gets shorter under a load, it is called a concentric action. What's it doing right now? It's maintaining its position under a load, right? This maintaining a position under a load is referred to as isometric. Iso meaning the same, metric meaning length. Okay? Isometric is this action. Okay? Now, what is the distal function of my hamstring? Let's think about this. What's the distal end of my hamstring attached to? Let's find that right now. Everybody find the distal attachment of your hamstring muscles. They're on either side. Reach down around your knee. You find these big cord-like tendons on the back side of your knee. Those wrap around and attach to the lateral and medial side of the femur. Okay? I'm sorry, the tibia. The tibia, right? Tibia is down here. This area right around the front is referred to as the tibial plateau, right in here, and the hamstrings attached to either side of that. So this is the distal end of my hamstring, right? That would be the insertion in that terminology of the hamstring. So what is the distal function of my hamstring? It does something to the knee joint. It's flexion. The distal function of the hamstring is knee flexion. Okay? Just like the distal function of my bicep is elbow flexion. We want to know what the muscle does to the joint. Okay? Now, what is this action called? Hip flexion. Hip flexion. What did that? What muscles performed hip flexion? Well, they call them the hip flexors, but It involves several muscles of the upper part of the thigh, and those would be the proximal aspects of the quadriceps and the psoas and some of the other muscles. We refer to those collectively as the hip flexors, the ones that make hip flexion. What extends the hip? The hip extensors extend the hip, and for our purposes this weekend, we're going to refer to those muscles as the posterior chain. The posterior chain is composed of all of the muscles of the glutes, all of the muscles of the hamstrings, and all of the muscles of the adductors. Those three muscle groups form the large group we call the posterior chain, and they're extremely important in human performance. One of our big jobs this weekend is going to be to teach you how to use those when we squat. Okay, the hip extensors, the posterior chain. Most people like to squat with the anterior stuff, right? The stuff you see in the mirror, right? Because it's easy to see it, you know, looks neat. Ooh, there's a cut in my quadriceps are all cut up here, right? Ooh, look. Oh my God. Because our eyes are on the anterior side. We are anterior-based creatures because that's what we can see if we look down. If we use a mirror, a relatively recent invention, I suppose, if we look in the mirror, what do we see? What's looking back at us? The anterior side. We pay very little attention to the shit back there. Everything up front we kind of know about, don't we?
Don't you think it's just like a natural tendency for people to just feel that more? I mean,
sure.
They don't defer to the posterior.
That's absolutely true because nobody ever really relates to their you can't see it. You can't see your hamstrings. Under normal circumstances, you can't see them. You can't watch them work. You can't see your glutes work. You don't know what the hell your adductors do. But quadriceps are pretty obvious because you look at them when you sit down. You look at them when you look down. And you have more of an attachment to them neurologically because of the feedback you get when you watch things work. If you turn sideways in the mirror and you do this, you can see your triceps, so a lot of people know what they are. If you do this, you can see, especially me, because I've got such massive lats. I can see my lats from the anterior real easy because I've got huge lats. Okay. So some things, most things that are anterior, we're easier connected with. Our job this weekend is going to be to shift our emphasis back to the posterior, to pull all of that useful muscle mass into our training and learn how to recruit it, learn how to use it when we pull and when we squat. Okay?